a relation on a set here. It's a subset of Cartesian product. Is a subset of Cartesian product. Maybe you know that A Cartesian A is equal to A و B such that A و B belongs to A. This is Cartesian product. I teach the Cartesian product last week, and you know that by Cartesian product I make cylinder, استوانه, and core, sphere, and some other beautiful geometrical picture. Okay, the Cartesian product is important. A relation on a set is a subset of Cartesian product. For example, a relation. A relation x less than y is a relation on R. For example, you say that 2 is less than 3, or minus 1 is less than 0. This is a relation on R. Here in book there is a examples for this that on the people of world. Let P denote the set of all people in the world, and define P is a subset of P times B, and D defined by this x and y such that x is descendant of y. Descendant means nave. In Persian we say descendants as nave. Olad, walad. In Arabia we say walad. Muhammad bin Zayed. Muhammad is the walad of Zayed. Karim ibn Mahmud. Karim is the son of Mahmud. Karim is have a relation with Mahmud. Okay. And the other. Okay. This is a relation. This is a relation on the people, and we say that we see that two other relations defined as follows: P and S. P defined as x and y such that x has ancestor who is also an ancestor of y, and S, x and y such that the parents of x are the parents of y. Then x and y are sister or brother. Okay, sister or brother. Okay. However, there are equivalent relation. What it means? An equivalent relation on set is a relation that has three properties: reflexivity. X has a relation with x. Symmetry. If x has a relation with y, then y has a relation with x. And transitivity. X has a relation with y has a relation with z, then x has a relation with z. I explain it here. Reflexivity. X has a relation with itself. Okay. For example, I can say that 2 less than 2. This is true. Okay. Symmetry. X has relation with Y, then I can say that Y has a relation with X. For example, X is X is less than 2 is less than 3, I can say that 3 is less than 2. This is symmetry. And transitivity. Transitivity. It says that if X has a relation with Y, Y has a relation with Z, then X has a relation with Z. Has a relation with Z. For example, X less than Y and Y is less than Z. Then I can say that X less than Z. This is transitivity. Then we can say that this is transitivity. Okay. We have some equivalent relation in nature, in mathematics. For example, 2 in English what we say is I write in English 2 is a divisor of 4. Okay? This means that 4 divided by 2 is 2 is 0. Okay? This is I check that this is equivalent relation or no. We can say that X is divisor by X. For example, 4 divided 4. This is true. X divisor by Y, can we say that Y is divisor of X? 2 divided by 4, can we say that 4 divided by 2? This is not. This is not. Okay? Then this is not symmetric. This is not symmetric equivalent relation. This is not equivalent relation. Okay. What about in X less than or equal to Y? Is this relation is an equivalent relation on R? I check it. First of all, X is less than itself. Okay? Then we can say that reflexive is reflexive. Okay? X less than Y, can we say that Y is less than X? Yes. Yes. Then is symmetric. X less than Y and Y less than Z. Then we can say that X less than Z. Okay, this is trivial. then we can say that this relation is transitive. Thus, R and this relation is a pair of equivalent relation. Okay. I come back to the book. I come back to the book. Okay. Okay. What is the equivalent class? What is the equivalent class? I define it here. Given an equivalent relation on a set of and an element x of R, we can define a subset of R called equivalent classes of determined by x. By the equation, E is defined as elements of R such that is equivalent with x. Equivalent with x. Okay. This is a class for x. Some books write it ex. Okay. Equivalent class of x. All of members that are equivalent to x. All of members that are equivalent to x. Okay. The equivalent class determined by x containing x, because x equivalent with itself. Okay. It has the following property. The following property. Okay. Two classes E and E prime are either disjoint or equal. This is a proof because let E be a equivalent class determined by x and E prime be the equivalent classes determined by x prime. Okay. I give a picture for you. This is R. Okay. This is E. This is E prime. Okay. This begin with x. This begin with x prime. Okay. Suppose that E intersection with empty is not empty. This means that they, for example, they have a joint in, for example, Y. Okay? Y be the intersection of E and E prime. We show that E is equivalent to E prime. Why? Y is in E. Okay? Y is in E. Then Y has a relation with X. Is in equivalent class. Y is in a prime. Then Y equivalent to X prime. Okay? From them we see that X equivalent with X prime. Okay? Now if W is a if if W is a point of E, okay, we see that W is equivalent with X, and it follows that by this and this, that W is equivalent to X prime. Okay, W is in E, W is equivalent to X prime. It follows that W is belong to E prime. Okay. Since W is arbitrary and we choose it from E, it belongs to E prime. It belongs to E prime. Then we can say that W is a subset of. Excuse me. E is a subset of E prime. By the same method, I can say that W is a subset of E prime. This implies that E is equal to E prime. E and E prime are equal. I explain it again. I explain it again. Okay. This is a set. Okay. This is the equivalent class of X, and this is equivalent class of X prime. Okay. E. Okay. Can E X. This is X. This is EX. This is EX prime. The equivalent class of X and X prime. You see that they can be disjoint, completely disjoint. Okay, is equal to empty. Okay, this finish the proof, but we say that this is not true. Okay, for example, they have a joint intersection in a point. For example, we say it's Y. Then this is complete from cross this point, and this is also, for example, this. Okay. Y belong to EX. Y belong to EX prime. Okay. Then Y equivalent to X. Here Y equivalent to X prime. By transitivity condition, we can say that X equivalent to X prime. Okay, this is trivial. Now we choose a point from X. Then we can say that W is equivalent to X. From this one, 1 and 2. 1 and 2 tell me that W is equivalent to X prime. Then W belongs to EX prime. Okay, W is from EX. Now W is a element of X prime. Then we can say that E is a subset of E prime, and the otherwise is true by the same method. Okay, by the same. However, okay, I come back to book. Okay. we have a partition. In your home, you have partition. What we say, a suite or a room for children, a room for cookie, a room for restroom, and other. Okay, if you have a home, okay, you have a restroom, suite for children, suite for yourself, suite for cooking. Okay, this is a partition of home. We have the same partition for a set. What it means? A partition of a set is a collection of disjoint non-empty subset of A whose union is all of A. I explain it here. For example, this is this is a set A. Okay, I can choose this partition. Okay, then you see that the A is divided to 1, 2, 3, 4, 5, 6. A has 6 partitions. Okay, I say it A1, A2, A3, A4, A5, A6. You see that all of AI disjoint from others. AI intersection with AJ is empty. Okay, and the union of AI is A. Okay, from 1 to 6. Other examples. For example, this is a rectangle. Okay, I can give you many partitions for it. This is a partition 1 and 2. Okay, A1, A2. Or here I give this partition. Okay, you see that this is A1, B1, B2, B3, B4. Okay, they are disjoint and their union is rectangle. In geometry, for example, this is R. Excuse me. This is R. Okay, 0, positive infinity, negative. Okay, I can give you this one, this and this one. Indeed, R can be written minus infinity 0 union with 0 plus. Okay, then R has 2 partitions, this one and this one. Okay. I give you other partition for R. Okay. R can be written as Q union with Q complement. Rational number and irrational number. Rational number and irrational. This is rational number, rational. This is irrational number. For example, 2 is rational, but radical 2 is irrational. Okay. Or I give you for R2. R2. This is R2. R2. Okay. You can see that I can give you this partition. This one, R1. This one, R2. Anybody? Hello. In a moment, we have a disconnect internet in Iran. Okay, I explain it again. This one is a partition R2. This one is R3, and this is R4. As you see, R4, R2, R2 can be written R1 union R2 union union R3 union R4, and you see that R1 intersection with R2 is empty, R1 intersection with R3 is empty, R1 intersection with R4 is empty, and the others. R2 intersection with R3 is empty. R2 intersection with R4 is empty. R3 intersection with R4 is empty. Okay. Then R2 can be parted by four partition. Okay. I come back to the book. Okay. I explain. Okay. We have another relation, order relation. Order. The order is important. Some books say linear order. Comparability. It has comparability. Indeed, for every x and y in R, x, y is not equal. X has a relation with y, or y has a relation. Non-reflexibility. For no x we have this one. This the reflexivity is not for. Transitivity. I give an example for you. Order. This one. This is a order on R. Okay. For example, we can say that 2 is less than 3. Okay. Then 2 has a relation with 3. 2 has relation with 3. Okay. We cannot say 3 less than 2. This is not. Okay. Then is non-reflexible. Okay. I can say that 2 is less than 3. 3 is less than 4. Then I can say that 2 is less than 4. Then this is transitivity. Thus, R and this relation less than is an order sets. Okay, ordered, and this is a order on R. This is a order on R. We have this is order on R, but I can say that this is not order on R2. Is not order on 2. I cannot say 2 and 3 is less than for example 3 and 4. What this means? It is not. It has not meaning. It is not a good relation. Okay. Indeed, this is a is an order on R. On R is order, but on R2 is not order. Okay. I hope you understand. I come back to book. Okay. We have some examples here for you. Okay. Yes. Abdul Salam Taha. Yes. What you say? I enable the microphone for you. Yes. Okay. Do you have any question?
نعم أستاذ.
Yes.
دكتور.
Yes.
نعم دكتور.
Okay.
نعم دكتور.
Here is a definition. If x is a set and less than is an order relation on x, and if I is less than b, we use the notion A and B to denote the set of X such that X between A and B. We say that in open interval. For example, 0, 1, 0, 1. 0, 1 is an open interval. Here 0, here 1. This is an open set in R. If this set is empty, we call A is immediate producer of B, and we call B the immediate successor of A. Okay, and we have order type, another order type. This definition. Okay. Suppose that A and B are two sets with order relation for A, and this is relation for B. We say that A and B have the same order type if there is a bijective correspondence between them that preserve order. What it means? If there exists a bijective function from A to B such that A1 is less than A2, then FA1 is less than FA2. I explain it here for you. This is A, it's this one order, and this is, for example, B with this one. Okay. For example, this is X and this is Y. Okay. X is less than Y by this order. Okay. And if I can find an F between A and B such that F X here and this is F Y. Okay, Fx is less than with this order on B than Y, then we say that they are have a relation. A and B order type. They have order type relation. Order type relation. I come back to book. Order type. They have the same order type relation. Okay. Here an example, very beautiful example for same order. Same order. The interval -1 and 1 and R. Okay. I define F as follows. Fx is equal to x over 1 minus x2. Okay. For example, minus half is less than. Okay. Then we can say that F is less than F. Okay. This is whole. Then we can say that -1 and 1 has the same order with R. Same order with R. Okay. Also, we have another example, example 10. You can see that it's interesting. And this is dictionary order. Dictionary order. We delete this from our studying. We don't need to this and don't study. Okay. Supremum and infimum. Supremum and infimum. Okay. Everybody, I finish my teaching here. I finish my teaching here and come back after 10 minutes. After 10 minutes. Okay, everybody, understand? Okay, okay. I come back after 10 minutes. Hello, everybody. Do you have my voice? Okay. تشکر سجاد آل حیف عبدالسلام طاها غسان الاسناوی و حسن زایر. Okay, I continue my teaching by supremum and infimum. Okay, we have a supremum and infimum on set, on an ordered set, on an ordered set. An ordered set of is said to have least upper bound property, least. If every non-empty subset A0 of R that is bounded above has a least upper bound. Okay, and also the set I is said to have greatest lower bound property if every non-empty subset A0 of R that is bounded below has the greatest lower bound. Okay. For example, let us consider this one. This one. This is R, and this is -1 and 1. Open interval. Open interval. Okay. Every set in I is between 1 and -1. Okay. 1 and -1 is not belong to I. But every x belong to I is less than 1. Okay. And every subset of I, for example, minus half and 9/10, okay, is belong to every element is here, is every element is here. We can see that x less than 1. Okay, 1 is here supremum, and -1 is infimum. Okay, but here I -1 and 1. 1 is maximum, -1 is minimum. But in open interval, 1 is supremum, -1 is infimum. Okay? Understand, everybody? Understand? Okay. 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 I come back to the book. Okay. Here there are some exercises for you. I hope you have time to do these exercises. They are simple. For example, this one. Define 2 points of a plan to be equivalent if y0 minus x0 power 2 is it. Check this is the equivalent relation and describe the equivalent classes. Okay. In R2, okay, this is 2 points. Okay, this is x0, y0, and this is x1, y1. They define that R1, R2. R2. They say that R1 is equivalent to R2 depend on the y0 minus x0 power 2 is equal to y1 minus x1 power 2. Okay. First of all, every point R1 has a relation with R1. Okay, because x1 minus y1 y1 minus x1 power 2 is equal to y1 minus x1 power 2. Okay, it has symmetry. R2 is symmetric with R1. Also, you see that R1 symmetric with R2. R2 has a relation with R3. Then we can say that R1 is equivalent to R3. Okay, I check this for you. It is whole. But what is the equivalent classes? Huh? Equivalent classes. The classes of X, a point R. Okay, X, Y is such that R prime, X prime, Y prime, such that Y prime minus X prime power 2 is equivalent to Y minus X2. Okay. For example, 0, 0, 0, 0. Okay. What is the equivalent class of this? Okay. We see that of prime, X prime, Y prime, such that Y prime minus X prime power 2 is 0. Okay. Then Y prime is equal to X prime power 2. Okay. This is this picture. This picture. Okay. The equivalent relation of 0, 0, 0, 0. I say O. The class of O is here. This one. Okay. Then I can say that 2 points is in on a same set hyperbola. Hyperbola. This one. This is a partition for R2. This is a partition for R2. Okay. They are very easy. They are very easy. I come back to some beautiful picture in mathematics. Equivalent relation in geometry. Okay. Let R is 0, 1 Cartesian product with 0, 2. Okay. Let this is a relation on R, and we define x, y is equal to x prime, y prime, if and only if y, I give you picture here. This is 0, 1. And this is 0, 2. Okay. Then the Cartesian product of them are, excuse me. Okay. Here we say that this one is equal to this one. This one is equal to this one. In these points are equivalent. Okay, this point is equivalent to this point. Okay. For example, this point is equal to this point. Okay. And I can say that, for example, this point is equal to this point. Tell me that what I get. What I get. Tell me that our this relation, what is it? Can you tell me? I explain it again. I explain it again. We have a rectangle. We have a rectangle, okay? This rectangle. Okay? And this point is equal to this point. This point equal to this point. This is equal to this point. And this is equal to this point. Okay? This is up. Okay? For example, this is x. This is y. X has an equivalent relation with y. Okay? A, B. A equivalent to B. Okay? Tell me that uh, uh, what we can get from this equivalent relation. I write it. Tell me what is the finalized picture by with this equivalent relation. Anybody, can you tell me? Can you tell me? No, مستطيل no. No. Kassan al-Hasabi. Tashakkur. But your answer is not true. Abdul Salam Taha. Hassan Zahir. Can you tell me? Okay. I tell you. Look at this picture. We attach this point to this point. This point to this point. This point to this, and okay. Then what we get? What we get? Look at this picture. This is rectangle. Okay. This point is equivalent relation with this point. This point is equivalent to this point. Okay. Then I must attach them. I attach them. Okay. Okay. Here and here. Then I get a cylinder. Okay. I attach this one to this one and this one to this one. Okay. I get a cylinder. Understand, anybody? I attach the equivalent points to them. I attach them. Any equivalent points, I attach them, and then I get a cylinder. We say cylinder. Ostovane. Ostovane. Cylinder. Maybe I must write cylinder. Hi. Hal Davaran. Yes, Davaran. Teşekkür. Hassan Al-Asmavi. Teşekkür. Davaran. Yes. After Davaran. Teşekkür. Teşekkür. Okay. Now you tell me another question. We have a rectangle. Okay? We have a rectangle. And this part is equivalent to this part. Okay? For example, this point is for this point. 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 Okay? And others. This side is equivalent to this side. Okay? And this side is equivalent to this side. Okay? They are equivalent. Okay? What we can get? Anybody, can you tell me what we can get from this equivalent relation on rectangle? Mustat Krat. I don't know what it means. We get tire. Tire. What you say in Arabia, tire? What you say chat? What you say in Arabia, tire? Ball? No, no, no. Tire, tire. Let us this. أثار العجلة. أثار العجلة. Lastic. أثار. I say in Arabia, I find أثار. 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 أثار هوا. Horse. Azil. I don't know what it means. Lastic. Matat. Lastic. Matat. Okay. However, this is this one. Okay. Okay. Then I attach them to this side to this one. I attach this one to this. Then I have a tire. Okay. Tire. Okay. For the car, you have tire. Okay. Tire. Okay. Then rectangle under this equivalent relation became tire. Tire. Okay. Another. The final. The final. We have a rectangle. Okay. But this side has equivalent relation with this side in opposite direction. In opposite direction. In opposite direction. For example, this point is equal to this point. Okay. This point has a relation with this point. Okay. This one has a relation with this one. This one has a relation with this one. What we get from this equivalent relation? Can you tell me? Murtaza al-Mashari, Salamun alaikum. Halqa, no, no, no. We give a complex picture. You take a rectangle and do this one. You choose these 2 points to them, okay, equivalent, and these 2 points equivalent to other points, okay. You must turn this side to this side. You get Mobius span. Mobius span. I try to find it for you in internet. Okay. Okay. Um, Oh, okay. This is Mobius band. This is Mobius band. I give you other pictures of Mobius band here. Uh, this is not the Mobius band that comes from this equivalent relation. Okay, I give you TOSI. Okay, okay, uh, okay. We have a rectangle here. Okay, we have a rectangle here. Okay, I must attach this point to this point. Okay, A to B. Okay, I have no choice other than give a curve. Give a curve to this point. Let us find the suitable word. Evolution, yeah, or revolution. Okay, rotation. I give a rotation. Okay, then I okay, okay. This is B. Okay, give a rotation that comes down to here. Okay, then I attach them these points. Okay, understand, everyone understand what I say? Let us find a suitable picture. Let us find a suitable picture. Give me only 2 minutes. I find a suitable. Okay. I try to find on internet suitable way for Mobius band or Mobius strip. Okay. but I don't find a suitable way. I give you a address for finding Mobius bundle in internet. I sent you for Mobius bundle. Okay. Indeed, in picture, I give a turn. I give a turn to this. I turn and this one goes to this one. Okay. Let us explain it. Okay. This one A is equivalent. This one P. Okay. I have no other way to turn and turn this one to this one. Okay. Then I have this one A and this one, but B. Okay. I don't how I picture. I give this picture for you. This is this one. This one goes to this one. Okay. We turn it. We turn it. We give a rotation to this point that goes to other side. Okay. By pinching it. Pinching it. This one goes to this one. Unfortunately, I don't find a okay. I find it. I find a I find a suitable picture. Please wait. Okay. Okay. This is a explaining for how we get Mobius band from a rectangle. Okay, understand Kassan Al-Hasnawi, Sajjad Al-Hikri and Abdus Salam Taha. Understand? Teşekkür Kassan, teşekkür. Okay. How? Now you tell me that if I have a rectangle such that this side has a relation with this side by in opposite, and this side has a relation with this side but opposite. Tell me that what I get. Can you tell me? We get Klein bottle. Klein bottle. I give you the picture of Klein bottle. It is Klein bottle. This is the bottle Klein that constructed by Klein. I give you other picture about bottle Klein. Okay, this is the bottle Klein, and it is a complex picture in geometry. The bottle Klein, the Mobius bond, tire, and also Ostovana cylinder. are 4 pictures in geometry that comes from a rectangle by different equivalent relation. Okay, I finish my teaching here. I hope you enjoy from this picture. I finish my teaching. في أمان الله. في أمان الله. Okay.